Okay, recording. So we know how to integrate this. I do. You should too. When we did U sub, there was something I told you about natural log. With natural log, what do you choose it to be every single flipping time? Anytime you see natural log, what is it going to be? U. U. Your U is always going to be natural log of whatever the natural log is. In this case, natural log of 2x. We're going to learn integration by parts today. The reason we do this is because y'all don't know how to integrate natural log yet. Today you'll learn. But every single time, even with this technique, if you see a natural log, or correspondingly the logs, that's going to be U. What is the derivative of natural log of 2?
1 or 2 over x. 1 over x.
1 over x.
Oh.
Because it's going to be 1 over 2x times the derivative of 2x, which is 2. The 2's factor out.
Oh.
The way I think about it is, I simplify that. Natural log of 2x is natural log of 2 plus natural log of x. Using log properties I tried to get y'all to remember.
Mm-hmm.
What's the derivative of a number? 0. So natural log of 2's derivative is 0. That leaves you with the derivative of natural log of x, which is 1 over x. So that's dx, right?
Yes.
Okay, so now we can integrate this because that thing, we could rewrite this, right? We could write integral natural log of 2x times 1 over x dx, right? And this is du, and this is u. And what's the integral of u du equal to?
U squared over 2.
U squared over 2 plus c. And what was my u? Natural log of 2x. But this whole thing is squared. You cannot simplify that. It's not like squaring the argument. You can't do anything with that. It's over 2 plus c. That's what you know how to do. Today we're going to learn to integrate natural log. We are. But in order to do that, because up till today, if I gave you the integral of natural log of x dx, you can't do this unless you choose u and the du is not there, so you can't do that. Can't not till after today. Can't do it yet, right? Not yet. And if I gave you the integral of x squared e to the x dx, you can't integrate that one either, because whatever I said look at the exponent, and that's your u. If that's my u, x squared is not my du, is it? So you can't do that one yet. Well, after today you will. We'll do this one later today, in fact. All right, so what does that mean? Why? I'm showing you why we're doing this. So now we can do it. And we need product rule. And believe it or not, this is a common theme in calculus and differential equations. In fact, I missed one of the homework problems because I was tired and I didn't see product rule going backwards. So if I have something where I have two functions, I'm going to call one u and one v. It's a very common thing in physics and calculus. So I'm going to take the derivative of a product. And the the derivative, I'm going to rearrange it to suit myself. You'll see in a minute. But do we all agree that you're going to take the derivative of one times the other unchanged and then plus the derivative of the first one, right? And I used to tell you, take the derivative of the first times the second unchanged plus the derivative of the second times the first unchanged, right? We're going to rearrange it a little bit to suit us for what we're about to do. We're going to take the derivative of the second one. So it's u times dv. Just leave it as dv for now. Plus the derivative of u, and we're going to put the v in front. Hang on, let me put the v in front. Let me make room. So we're going to do v du. So we took the derivative of the second one times the first unchanged plus the derivative of the first one times the second unchanged. Yes?
Yeah.
Yes.
So why is it on dx on the bottom?
Because you just humor me, okay? These are all with respect to x. We're not going to worry about what it's with respect to, okay?
All right.
Just it's a little bit of it's a little bit sloppy shorthand, but so if I integrate this and integrate this and integrate this, will I get back where I started to uv? uv equals the integral of u dv plus the integral of v du. And in this case, I want to solve for this. If I want to solve for the integral of u dv, where u is something it can take a derivative of, and dv is something I can integrate. That's what your goal is, because that's what this is for. Then would I just subtract this integral? Right? And what I end up with is that the integral of something that I can take a derivative of, something times something that I can integrate, is equal to ultraviolet voodoo. UV minus VDU. This is where ultraviolet voodoo comes from. It's a mnemonic. It's a way to remember it. So you're going to do UV minus the integral of V du every single time.
Wait, why do you want that equation?
Because it is a way to handle something when I have the product of two functions and one of them is not the derivative of the other. And so I have to break it into two parts. And what it ends up being is I'm using the product rule to do it. This is kind of the sledgehammer of second semester calculus. You bust it up into little pieces and you keep busting and beating on it till you get it down to something you can integrate. Now, the key to this is, one, you have to know all your derivatives, and two, you have to be able to integrate and know when you get down to something you can integrate and know to keep going, beating on it when you don't know how to integrate it. That takes practice. For me, it's kind of, it's obvious, but I know, I got hints for you. I will give you hints, because I know it's not obvious to you yet. Next page. Okay. Now, we're going to try an example, so I can show you why you do this, and how you do this. I have y equals to the integral of x sine of x dx. Is x the derivative of sine of x? No. Is sine of x the derivative of x? No. Then it's not a straight up u sub. Do you see that that's definitely not a u sub? But is it a product? That's your hint for it. It requires integration by parts. By the way, this is technically called integration by parts, not ultraviolet voodoo. Just repeating that. So what am I going to do? I'm going to look up here, and I'm going to find something up there that's, I'm going to choose as u. I'm going to choose u, and it's going to be something that's easy to differentiate. That is the verb for take a derivative. Differentiate.
So it's x?
Yeah. That's an N. Oh, I put too many letters in there. Hang on. I got lost. T8. It means it also is going to get simpler. There's things you can, there are things that you can take the derivative of that doesn't make it the thing you want to do because it doesn't get any simpler. The whole idea is you want to pick a u where if you take the derivative, it gets simpler and easier to handle. For instance, x, what's the derivative of x?
1.
What's the derivative of 1?
0.
Well, that's nice. So polynomials are really nice to take derivatives of, right? Much easier than integrating them. It's easier to take a derivative of them. So basically the way you choose this is you always pick something you know how to take a derivative of and can do it multiple times if you need to. Don't pick something you don't like to integrate. Well, there are going to be times when you have to, but for the most part, the way to think about this is you're picking the thing that's easiest to take a derivative of. That's your u. Well, that leaves whatever's left over. I'm going to choose dv, and that's going to be easy to integrate, right? Or you can integrate. Sometimes it's not easy, but you can integrate. Don't choose something you can't integrate. That's not going to be helpful, is it? So in our case, sine of dx. I mean, you don't like to integrate it, but can you? Yeah.
And then it goes.
Yeah. And the reason we choose x as our u is because, yeah, you can integrate that, but if you take its derivative, does it get simpler? If you integrate it, does it get simpler? No, it gets more complicated, right? It's going up in order. You want to go down in order. So let's try this. We're going to choose u to be x. What's the derivative? So what's du equal? Dx. That's wonderful. We're going to use that in just a minute. All right, then we're going to choose dv equals sine of x dx. And guess what we're going to do? We're going to integrate both sides. That gives me v equals, what's the integral of sine of x?
Negative cosine.
Negative cosine of x. Don't worry about the dx.
Does it go away?
Well, we just chill. We're going to get something eventually, but we don't need double dip, okay?
Mm-hmm.
It would actually be a plus c, not a dx, but we don't need the plus c till the end. Don't put it in the middle. You're going to put the plus c at the very end because we're going to have, if this, some of these work where you only have to do this once. Other ones you have to beat on it a couple of times to get the answer. Wait till the end to add the plus c because otherwise you get all these c's.
Yeah, that's weird.
Yeah, that's weird. All right, here we go. So you ready? So that means that y is equal to uv. uv. Right? uv minus the integral of v, negative cosine of x, times du, which is dx. Did I get it down to something that you can integrate?
Mm-hmm.
So this becomes negative x cosine of x. And then minus the negative means it's plus. What's the integral of cosine of x?
Sine.
Sine, right? So it's plus sine of x. All right, I'm done. I've gotten rid of the integrals. Now do I add my plus c at the very end?
Mm-hmm.
Yes.
That's nice.
就是这么简单。
That's what y'all, yeah, they're like, huh? Whatever. I heard something. Mrs. White was talking. I have no idea what the woman said. Black magic as usual. Oh, now, that's an easy one.
Which one?
This is an easy one. It's obvious, it's easy. After I finish getting all the way through this will be an easy one. This is not one of the hard ones. This is, I mean, guaranteed on the test there's kind of a problem.
Like one problem.
No, there's going to be more than one problem.
Oh.
But there's going to be that level of easy on the test. There's going to be a medium and there's going to be a hard. All right, next example. Let's turn up the heat. Our potion's not ready. Remember I promised that I would teach you how to integrate natural log? Here we go. What did I say every single time? What do you always choose natural log to be? U equals natural log of x. What is the derivative of u?
1 over x.
1 over x dx. Now, that means that x is the only thing that can be dv. dv equals dx. Integrate both sides. What does v equal? X. So this will equal my u times v. So I'm going to put the v in front. But that's okay. Is that uv? Is that what that term is? Sorry. Yeah? Minus the integral of v du. What is x times 1 over x?
1.
1. What's the integral of 1? X. So this equals x natural log of x minus x plus c.
É tão fácil.
So now you can integrate natural log of x. But even there, even when we were integrating it, did we pick it to be u? So that still stands. Anytime you see a natural log, that's going to be your u. That's always your first choice. That one, there is no question. You have to pick it as your u. Or else. Or else we're way beyond what I'm teaching and something nastier is out there. This is choosing the least of the evils. Lesser of many evils. These are many evils. Okay, well, can't get away without doing an exponential. Remember how I said I'd do that exponential one too? Well, we're going to do it now. I'll show you how to do it. We had y is equal to the integral of x squared e to the x dx, and we were supposed to integrate that. What you going to choose is u.
X squared.
U equals x squared. So what's du equal?
2x dx.
2x dx. Oh, I see trouble, but let's keep going. It's okay. All right. Now, what's my dv equal?
E to that.
E to the x dx. Go ahead and write down e to the x dx. If I integrate both sides, that means v equals e to the x. Don't do the plus c till the very end, right? Y'all don't see the problem yet, but I do. Okay, so what does y equal? Let's go ahead and write this out. So y equals uv x squared e to the x minus the integral of v e to the x du, right, which is a 2x dx. And do you see the problem?
Yep. So
2x is still not the derivative of e to the x. I mean, it's still not right. Uh-oh, we gotta do it again. Uh-oh, spaghetti-o. So this time, this is gonna be my u, and e to the x dx is it gonna be the same dv? So we just need so that was like the first time. That was the first time through. Here's my second time through. U is equal to 2x, so what's du equal? 2 dx. And my dv is the same way, so I don't have to worry about that one, right? So I can just go ahead and, so what does this equal? The first term is still the same. I'm just trying to break up this integral, right? So it's minus, and I put parentheses. The uv for my second time around, u was 2x, same v, it was e to the x, minus the integral of v, which is e to the x, du, which is 2 dx. Now, can you integrate it? Not up and down, yes. We're going to distribute the negative signs. Notice it was minus the first time, but it's minus again. Does that make it positive now? You'll see why that's important in a minute. It's going to alternate signs. So x squared e to the x minus 2x e to the x plus 2 integral of e to the x dx. And what does that equal? Y equals the x squared e to the x, which is the first term, minus 2x e to the x for the second term. And then what's the antiderivative of e to the x? So it's 2e to the x plus c. I had to do it twice. Yes. Would you like to know a shortcut? Because can you imagine if that had been something besides x squared? What if that had been x to the 5th? Do you realize how many times I have gone through with somebody their work to find all their silly sign mistakes? I'm about to show you the table method. If you use this method, it takes care of the sign for you so you don't make the sign mistakes. Y'all drop negative signs all over the place. Use the table method. And so see what we did here in that first one? You're going to do that first step. We always do that first step. And then we use the table. As soon as I see that it's going to take more than once, I go down here and I do the table method. I'm going to have a sign column, oops, as in sign plus or minus. I'm going to have a u column, and I'm going to have a dv column. So my sign is going to start off positive. It's positive. U in this case, what did we pick u to be? X squared, right? And what do we pick dv to be? E, so it's e to the x. We don't write the dx here. I'll show you why. Because when we integrate it, is this what we're going to get? Okay, we're going to alternate sign. So the next step is minus. What's the derivative of x squared? 2x. What's the integral of e to the x? E to the x. Uh-oh. Well, we know we're not done yet. So plus alternating signs. What's the derivative of 2x? 2. Is the integral of e to the x still e to the x? Yup. And for our last one, minus, actually I don't like that, minus alternating signs. What's the derivative of 2? 0. What's e to the x? If I just keep going, will it always be e to the x no matter what? Right? Here's the way it works. You're going to follow a path. You're going to start on the first line, you're going to go straight across. So it's going to be a positive, so it's positive 1 times x squared, and the x squared is times 1 row down e to the x. Then you're going to go to the next row. You have a negative 1 times 2x times e to the x. Look at that first row. Is that the first term? X squared e to the x. Look at the second one. Minus 2x e to the x. OMG, guess what? We're going to keep going. If we go across, do you see that it's 2 e to the x? If I do it again, do I just get 0 and I get to stop? So you don't have to write this last line. You don't have to do this at all. You don't need this, because as soon as you see that this goes to 0, as soon as you see that 0, you stop. You keep going down here till you find a 0, and then you stop. You don't have to write that step. Do you understand what I'm saying? I just wrote so you would see that 0 times it is 0. You don't have to go any farther. As soon as you see there, that's where you stop. You look for that. Would you like to try another one?
Yes.
But before we do, let me give you my hints on how to choose wisely. Here are hints. This is what Mrs. White's hints on choosing you, because I choose you.
Okay, thank you. Choose what's easiest.
That you're choosing it based on what you pick for you. So they have these acronyms. I don't like them,
Late.
but I'm going to give it to you. I don't like this one, but this is the one I use. And then Lipit, if you go online and you Google it, there's a calculus song, Lipit to Whip It. Lip it good. Dun, 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 dun. It's music from my time in college. You don't dance to it, you just jump up and down. It was great workout. Okay, so you should listen to that. It's pretty funny. But it's Lipit. Well, it doesn't really matter. The L stands for the same thing. What did I tell you a minute ago that you always pick as you? Natural log. Is it a log?
Yeah.
L stands for log, which means it's the natural log, right? Both of them log. If you see a log or a natural log, that's going to be your first choice for you, because you don't know how to integrate it. You only know how to take its derivative. Agreed?
Agreed.
Agreed. Okay, then there's inverse trig.
Oh.
Yeah. Do you know how to take the integral of an inverse trig? No, you only know how to take the derivative of it and integrate its derivative. For inverse trig, do we learn to integrate 1 over 1 plus x squared? We did not learn to integrate inverse tangent, did we? Inverse tangent was the answer, not what we're integrating. So anytime you see inverse trig, all of this makes sense. If you see inverse trig, please pick it as your u and go take its derivative. For the things you only know how to do a derivative for, you choose those and take a derivative. Okay, then there's algebra. Is that just a polynomial? Because if you choose a polynomial, if you take its derivative, eventually we get to 0. Yeah. So the reason I like this one is it's because it actually says polynomial in the acronym. Then, for this one, the reason I don't like this one, they picked trig, and I think that's a really bad idea. These last two steps are a preference thing, but I'm going to give you advice. The last one's exponential, that's e to the x. For this one, they switch it. They do exponential first, which is e to the x, and then they do trig. Do we all agree that you can both integrate and take the derivative of all the trig functions, and you can integrate and take a derivative of e to the u, or e to the x, right? You can. But my personal opinion is y'all do much better at taking derivatives of trig functions. Y'all are not so good at integrating. Y'all do better, you're better at derivatives than integrating, but integrating e to the x is not as hard as integrating trig functions. There's just too many things to remember for that. Derivatives is better. So I prefer this order. This is the order I prefer. It'll work this way, but there's more chances for you to make a mistake. I prefer this order And if you think about it, it makes sense on how you choose them. If you have algebra with either one of these, you're going to pick one of those as the log or the inverse trig as your derivative, and the algebra will be integrated. Because you can integrate algebra. You can. You may not like it, but you can do it. Okay, let's try another one. Do we all agree that certain trig functions like sine and cosine, you could take this derivative and do it all day long and never get anywhere, right? Backwards, forwards, change the sign, backwards, forwards, change the sign. What about e to the x? You can take its derivative for forever. You keep getting e to the x, right? Is that combo the one that right here, oops, is that what this is all about? Because with those two, I'm telling you, you should choose the trig function to be your derivative and the e to the x to be your integral. Because just what I know what y'all are capable of. So let's do that. This is example 4. And it is y equals the integral of e to the x cosine of 2x dx. Oh, u. So what are we going to choose as our u? Because y'all do much better at that. So choose u as cosine of 2x dx. Sorry, not dx, just 2x. For each one of these, you're going to do this one time. Just do it one time, and then you're going to do the table. And I'm going to show you that this is tricky. All right. So what's du?
Negative 2 sine.
Negative.
Yes, negative 2 sine of 2x dx. Got it? What is my u? No, I'm sorry, what's my v? dv. Sorry, dv. dv equals e to the x dx. Integrate both sides. What does v equal? E to the x. I just need one step. I can look at this right now and go like, oh, this one ain't going away. Nothing good is happening right now. Ain't nothing good happening. So we're going to go to the table. Okay, table. We have sine, we have u, and we have dv. Sine is always starting out positive. Got to keep it positive. My u is going to be cosine of 2x. My dv is e to the x dx. We're just going to leave off the dx because we're going to save it for the very end. Yeah? Okay. My next step, I know it's minus, and I already did it right there. So it's a minus a negative 2 cosine of, sorry, I did that wrong sign. Sine of 2x, right? And the integral of e to the x is e to the x, yes? Next step, plus, what's the derivative of negative 2 sine of 2x?
Negative 4.
Negative 4
2x.
cosine of 2x, right? What's the integral of e to the x? E to the x. Okay, we stop. Did you see that if we keep going, we're just going to be in a vicious cycle? Are we going to keep getting back cosine of 2x?
That's crazy. Wait.
Okay, that's crazy, except we're going to use that to our advantage. Whenever you get back to where you started, are you going to end up, when you do the product, are you going to end up with this times e to the x? Are you going to end up with that? But you just, what's the difference is you have a coefficient.
It's gonna keep getting bigger.
Can you use algebra to stop the cycle?
I mean, you can. but-
You're going to, or you can just get it wrong. Your choice.
Thing.
Well, so what is it going to equal? So when we go across, green. So we go across, right, and down, and we go across and down, and then you're going to go back this way. When you get to where that's repeating, you go back, and let me show you how you use it. This is going to be y equal to, and my first term is a positive cosine of 2x times e to the x. So I'm going to do e to the x cosine of 2x. And then it's going to be minus a negative, so that's plus 2 e to the x sine of 2x. And then my next term, so when we do the slants like that, that means you're actually integrating it. You've actually done, that's u, and you're doing u and v. Well, this step, what's going to happen is we're going to stop at the next step where we are doing an integral of a v to u. So it's a plus it's a positive 1 times the negative, so I'm going to end up with a minus. I'm going to pull a 4 out in front. Am I going to have the integral of e to the x cosine of 2x dx? When I do that. So what I've done is uv, this would be the next integral of v to u, and that means I have to do it again, so that's my uv, and now I'm doing v du. V du. I am doing, this is my v, this is du when I go this way.
But you already know what it is, right?
I do, because I knew back here that this was the integral. Where did we start? E to the x cosine of 2x dx. Is that the same darn thing? But I got 4 on this side, negative 4 on this side, and positive 1 on this side. Can I add 4 to that, both sides, and get rid of that? So I'm going to add 4 integral of e to the x cosine of 2x dx. I'm going to add 4 integral of e to the x cosine of 2x dx. Goes away. Do I have 5 integral of e to the x cosine of 2x dx is equal to e to the x cosine of 2x plus 2e to the x sine of 2x, right?
Wow.
Well, and then what do you divide by?
5.
5. And don't forget we add a plus c at the very end. We're only doing that at the very end after we've cycled through. Okay, I'm going to go to the next page and get the answer. Can I write that now?
You can just plug in the calculator. Oh, no, you can't.
No, you can't. Nice try. You can't.
Let's make a calculator.
It's called a computer. You're not allowed to use it in college or on the AP test.
Well, I'm screwed.
You could just learn the calculus and then it would be easier.
Yes. But like Miss Newman always says, why?
I'm just going to put this out front.
She says that.
Plus C. I'm going to erase this. I'll make a 1/5.
That's what I did.
Oh, wow. Well, that's slick.
Good job.
That's the answer. Okay. You will have a quick quiz on Monday that'll be over 7-1 from yesterday because I didn't want to give a quiz today. I have enough to grade. On Tuesday, you will have a quick quiz over this. On Wednesday, you have a quick quiz over partial fractions, which is what we're doing Monday. It'll be
Wait, Monday the quiz is over what?
oh my God. Yesterday,
Oh, we're
7-1. 7-1
Wait,
quiz
can
on Monday, 7-2 quiz on Tuesday, 7-3 quiz on Wednesday.
And then test Friday. I'm just kidding.
I should, but no, your test is not until after we finish chapter 8.
Alright, but I was like
I have
can
no
we do
excuse to fail.
this integration by parts with what we did yesterday or no?
What?
Can we do integration by parts with what we did yesterday or no?
Sure.
It would
I'm
just
not
be
going to do that. Y'all have enough. If y'all just do, that's a lot of combo of old stuff. That's bad enough, and this is bad enough by itself. I'm not combining this with old stuff right now.
Alright, just wondering because if I ever get stuck,
Yeah.
that's something.
Happy New Year.